Hey science fans, ever wonder how we measure change? Or how things add up over time? Well, there's a super cool branch of math for that. It's called calculus. And two of its biggest stars are differentiation and integration. Differentiation is like having a super-powered magnifying glass for change. Think about your car's speedometer. It tells you how fast you're going right now, at that very instant. That's what differentiation does. It helps us find the rate of change at any specific moment. So, if differentiation is about the right now, what's integration all about? Well, integration is like its awesome partner. It's all about adding things up. If differentiation gives you the speed at any moment, integration helps you figure out the total distance you've traveled on your trip. Integration sums up all those little bits of change to give us the grand total. It's the ultimate adding machine for things that change. Alright, let's switch gears from cars and pools to something even tastier: food. Imagine you're in a massive food factory. They're not just baking one cake, they're baking thousands. Or making tons of your favorite snack. How do they make sure every single item is perfect? One of the big secrets is something called mass balance. What goes in must come out or be accounted for somewhere inside the process. Think of it like a super strict recipe. You carefully measure all your ingredients going in. At the end, you expect a certain amount of yummy product coming out. Nothing just magically appears or disappears. Mass balance ensures consistency. You want your favorite cereal to taste the same every time you buy it, right? It's also incredibly important for safety. Food scientists need to track every ingredient to make sure the final product is safe to eat. By knowing exactly what goes in and what should come out, companies can reduce lost ingredients, saving resources and money. Now, how does our math buddy integration jump into this food factory fun? Remember, integration is great at adding things up, especially when rates are changing. In a real food factory, things are dynamic. The speed at which liquid chocolate is pumped into a candy bar, mold might not be perfectly constant. Differentiation could tell us the flow rate of chocolate at any single second. But integration? Integration takes all those slightly different flow rates over the entire time the mold is being filled and tells us the total amount of chocolate that went into that candy bar. This isn't just for chocolate, of course. Think about making fruit juice. Water might be evaporated to concentrate the juice. The rate of evaporation can change depending on temperature and pressure. Integration helps calculate the total amount of water removed over the entire process, ensuring the juice concentrate reaches that perfect, fruity punch. It's all about precision even when things are constantly in motion. Let's chew on some more real-world examples. Imagine a giant industrial bakery, churning out thousands of loaves of bread every hour. The system that adds water to the massive dough mixers might not deliver water at a perfectly steady stream. Integration is the tool engineers use to calculate the precise total volume of water added to each enormous batch of dough over the entire mixing period. This ensures that every single loaf has the ideal texture and consistency. Or think about something you might have for breakfast: pasteurized milk. To make milk safe to drink, it's heated for a specific time to eliminate any harmful bacteria. Integration helps food scientists calculate the total heat exposure that every single particle of milk receives as it journeys through the pasteurizer. Too little heat and the milk isn't safe. Too much heat and you can damage the taste and nutrients. So the next time you enjoy a glass of milk or a perfectly baked cookie, remember that calculus, especially integration, is working behind the scenes.